Some thumbs up, that's good. Right, well, for those who maybe haven't met me before, I was the Commodore of Dew Valley Lake Sailing Club about 20 years ago, and have been sailing for a very long time. And this is all about a crazy boat that I built half a century ago. Back then, I was relatively sane and sensible. And with my lovely wife, Gail, we used to sail Merlins. The picture on the left, weirdly, we're in the Mediterranean. And on the one on the right, you can see Bognor Pier in the background, which is where we learned to sail.
Doug, we're only seeing you.
What?
We're only seeing you.
Right, you're not seeing the screen sharing?
No.
All
I
right.
can see you.
It is.
I've got the
Yeah.
graphics, Doug. Yeah.
Yeah, we got it.
Yeah, it's okay, Doug. I've got you.
Looking good.
I think people who can't see it, I've got a technical problem their end.
Yeah.
Okay, right, keeping going. About that sort of time, I got interested in speed sailing and started going down to the Portland Speed Week in October each year. Here you can see Clifton Flasher, fine boat, got friendly with Nigel Irons, all sorts of other crazy boats. This thing on the left, which looked like a crashed glider, I think was meant to be a kite that was going to tow this thing. I'm not sure that this was very successful. I also had a great desire to own a Triumph Stag. And at that time, if you could win the World Sailing Speed Record, the prize was £2,000, which would buy you a Triumph Stag. And as a young naval architect and a sailor, it seemed to me really straightforward that that was the way to get my Triumph Stag. Now, at the time I had been sent to work at the Admiralty towing tanks down in Gosport, the delightfully named Admiralty Experiment Works, designing fins for submarines and things like that. And then I was sent to University College London to teach hydrodynamics. And this gave me lots of background in hydrodynamics and aerodynamics and control theory and all sorts of other stuff. And one of the delights was that one of my brothers, Dennis, was my student at UCL, and he was better at computers than I was. So we put together some computer programs to do performance prediction for various crazy machines. This was the sort of output that we got. So we could see which elements of the boat were creating drag, windage, and the struts and the lifting foils and so on and so on. And it gave us an idea of how fast the boat might go. So here we can see, 40 knots should be absolutely no problem. Fine theory. And this is the design that I came up with. The reason that I'm sitting in the middle is that the control aspects of this were quite difficult, and it was not possible to see how I could leap about the boat to balance it and control the foils at the same time. And so I ended up sitting in the middle. Once you're sitting in the middle, then this trimaran form seems ideal. Ben Ainsley is doing he hasn't got the little floats either side. So this machine was to be 20 foot long, 15 foot wide. And as you can see, the sail is not a normal fabric sail. It's completely...
Somebody not mute.
Somebody not mute, that's right. It's a completely solid wing sail. An Australian magazine described the boat as a crash between a dead insect and a crashed Spitfire. which gives you an idea of what the sort of thing the sail looked like. So I'm sitting in the middle with what looks like a steering wheel, but it's a control column like on an aeroplane. So it gives us height and roll. And there are two foils on either side of the crossbeam, little floats, which are really only there for when you're more or less stationary. Once you get to 4 or 5 knots, the hydrofoils are powerful enough to keep the boat upright, almost always. The all-up weight was about the same as an Enterprise. Bearing in mind that there's only one crew in this, but allowing for the 2 crew, it had about the same, 220 kilograms. That's about the same as, well, probably a Merlin as well. So with the foils squashed together to get it on the picture properly, that's what the foil system looked like. The tail foil is just fixed. I noticed that Ben Ainsley is allowed to move this a bit, which is helpful. Either end of the crossbeam, there are vertical struts and horizontal foils, which are all moving. Now, this sort of foil arrangement of its own is not stable in height. The normal surface piercing foils, angled foils, they automatically reduce the load as you go faster by coming out of the water. But these things need to have some form of stability built into them. On Ben Ainsley's boat, he has 2 pilots who spend their time making sure that he rides at the right height. And I used a mechanical system invented by a guy called Christopher Hook, where you have a surface sensor that goes in front of the boat. And as the boat drops and the sensor rises, it increases the angle of attack of the foil and basically keeps you stable. And Christopher Hook had built proper working varieties of this, and even built some landing craft for the US Navy based on it seemed the most unlikely application, but that's what happened. In my case, it needed more input from me because my job was to organize the roll, keep the boat upright, which meant moving the 2 foils against each other, and also getting the height right. And so I have a control input that comes into the float, and there's a little adding linkage here, which adds the input from the feeler arm, and then it all goes down wires into the strut and moves the foil. This was not a uniformly wonderful system, and when it doesn't work very well, then the boat leaps in and out of the water. When it works well, everything is smooth as silk. This is the sort of thing that was on the end of the control column. Only half the wires are shown here, but as you push the control column in and out, the foils on both sides are decrease in angle of attack, and as you turn the wheel, then they move against each other. This really worked very well, except that all 3 of my brothers did have a go at sailing the boat, and they all got out and said never again. And the fundamental problem was having a steering wheel in front of you and not using it for steering is really very difficult and requires a lot of thinking about. Now, the fundamental idea about the construction of the boat was that it would be done in our garage. And apart from the aluminium bits, which were done professionally, pretty well everything else was done in our garage. You can see the most vital piece of equipment just here was a bandsaw, which lasted me 40 years and was wonderful. So this is the this is the laths set up for the hull. And in this picture, the whole thing's been covered with 1 centimeter thick expanded polystyrene, lightest density. So it's a very light core and quite unusual for that. But I was put onto it by a Danish guy called Leif Wagner Smith, who had built some Little America's Cup boats. And he recommended it. And I have to say, despite the fact that it didn't look very robust, it proved very effective. So then Gail and I would cover this thing with glass cloth and splosh on epoxy resin. And we end up with a hull that looks something like that. For some reason, I got lots of pictures of my brother Dennis, he's the one with the beard, and not Gail, who did most of the help. As you can see, one of the crucial things about the design was that the connection between the crossbeam and the hull had to be really, really strong, because many of the people who went to the Speed Week suffered from really not having sufficient structural strength. And particularly with such a wide craft and the ability to run it aground, it would be very easy to have problems. But this all worked pretty well. So that's the crossbeam attached. The crossbeam was, at this time, Gail was working for Proctor Masts. And they generously gave me a bit of extrusion for a rather larger yacht, which had a slight twist in it and was going to go back for recycling. And they gave it to me at cost. So that was very useful. These little side hull floats are about 7 feet long. I seem to remember they weighed 5 pounds. So, and this nice brown color, the epoxy goes on yellow, but in the sun, it goes really attractive. It looks as if you've got a nice teak boat. That's the side hull. You can see the linkages in. Whoops. You can see the linkages inside, and this little lever here connects up with the strut and passes the signal down to the foil. Now, one of the problems with the trimaran arrangement that I had was that it turned out to be really quite difficult to work out how to stay the sail, how to stay the wing mast. One of the reasons for going for the wing was that I was very worried about the sheet loads that were going to be required for any sort of soft sail. And the big advantage of wings, as they found in the last lot of America's Cup, is that your sheet loads are really low. And to help that, I put the shroud fixings a bit back from the leading edge to again reduce the loading on the sheets. And there was a boom sticking out the front here with the main sheet on the end. Unfortunately, in order to be able to rotate the mast, the forestay and the shrouds have got to be slack, because otherwise they just immediately come up tight. And that means that the sail can just fall forward. So it has to have a backstay, which was a great disappointment. It means a very inefficient shape for the sail, but in the end, it sort of worked. That was the construction of the wing. So they had a D-spar in the front, and then ribs, which are made of expanded polystyrene again, and all covered with Melinex mylar film. And at the top, there was a bit of a flap. which was really there for aerodynamic reasons, to try and make the sail look broader at the top than it really was. So that's a cross section through the mast. So there's a big D section spar at the front, all foam sandwich again, foam sheet here, and a little flap at the back. For strength reasons, there had to be extra timber, spruce stringer put in either side to give the strength that was needed. On the left, you can see the D spar at the front of the mast. It's more or less as big as the boat. There was never any problem about it submerging. It got an awful lot of buoyancy there. And this is, once the Mylar film's been put on, it has the nice property that it shrinks slightly if you heat it. And so the way to tighten up all the panels was to iron it with a domestic iron. Unfortunately, I couldn't reach into the middle, so it had to be upside down. This is the final design of the lifting foils. They're, again, very much based on Christopher Hook's design, which was unfortunate because it turned out that they were absolutely fine for a motorboat, but it didn't work very well for a sailing boat where you're going to have an angle of leeway. And as soon as the leeway got significant, then one side would lift more than the other. And that was the main reason, we discovered years later, that was the main reason why we got jams of the foils. And they would then stop responding to what the helmsman thought was a good idea. That's one of the foils being made in the first place. This is an inch diameter stainless steel rod, and all being laid up with GRP and epoxy again. And then when it was finished, we had somehow to get it to Portland. And a friend very kindly lent us a quarter-tonner trailer, which had the advantage that it was heavy enough so that the whole lot wouldn't blow over. Although the windage was a significant problem, because the wing sails, I think 12 foot across, 12 foot maximum span at the bottom. And so you've got the hull there. Here the foils are on there as well, struts there. I don't know where the rudder is. Yeah, everything's there. Oh, where's the crossbeam? Oh, the crossbeam, you can just see one of the side hulls sticking out. The crossbeam's on the other side. So there we were in Portland. This is the first year we were on Chesil Bank on the inside. And that was just about the first time the whole lot had been put together. And that seemed vaguely all right. What did we learn that first year? Well, the first thing we learned was the sail was totally uncontrollable, not just slightly, but just completely. It turned out that putting the shrouds that far aft turned it into a kite. And so it would automatically, of its own accord, pull. And at the time, with the main sheet trying to pull it into the middle, there was absolutely nothing you could do. And so the first outing ended up with the thing. Did it capsize? Yeah, probably capsized. Going bow down 20 degrees, the rudder came out of the water, and it set off at a great rate with me crawling aft along the back deck trying to stop it. So we had to accept that the sail was going to be master of its own fate. So this was the next year, and by now we're in Castle Cove. Now, I don't know if anybody sailed at Castle Cove, but in order to get down onto the beach, there's a tunnel. And I can tell you that the tunnel is 12 foot 3 inches across, because you could just get the sail down the tunnel, just. Right, so it's all put in place. The struts have got little things to hold them up while you're launching. That's about the best picture that I've got of the cockpit. So this is the control column, a speedometer, which is a pressure gauge, and there's a pitot on the front of the rudder, and that seemed to work fine. Inside there are 2 foot pedals, and these are rudder lines here, coming back to the rudder. And it was light enough for 2 or 3 people to carry it into the water. This is the point where it's really helpful to have friends. And I was really grateful for my brothers and Gail. Because you need to get into about 4 foot, 5 foot of water in order to safely get the foils down. But it did float, and it sailed all right. When hull-borne, you've got the two vertical struts are just like really quite substantial daggerboards, and you've got a big rudder, and so it's perfectly maneuverable. So it's very, very easy to sail it around, no problem whatsoever. When I got to 20 knots, my brothers bought me a crash helmet. And it did fly. Sometimes, the first time it flew, I had no idea what was happening. It just was as if the tide had gone down. It was a very gentle day. And all of a sudden, you notice the water seems a lot further away than it had been. And then I expect it crashed. This is the sort of thing that was going on. This lovely boat here is an American boat. A group of rich businessmen bought it or had it built. It had 2 little floats on the end of a crossbeam here, which could be winched out either side. So you could winch these over one way, over the other way. And so the crew spent their time running up and down this ladder, trying to keep it the right way up. Unfortunately, it came to a bad end. It dragged its mooring, got hold and sank and was never seen again. I don't know what this is. There's all sorts of weird boats. At this time, the windsurfers were doing about nearly 20 knots, which was really annoying. But when you had a boat which had a large number of sharp points and sharp edges in the front, you felt that they kept out of your way. One of the problems with the boat was that there was no effort involved in sailing it. And so you get very cold. And on a windy day, you're constantly getting wet. You're not expending any energy, and you're just sitting there. And that was a bit of a disappointment. You don't realize that in a dinghy, the fact that you're working all the time is really helpful. This is a friend of mine called Ben Wynn, and his boat, Mayfly. She was the world speed record holder that year with a speed of about 23 knots. we managed to, not many of these boats could sail together because either one of them was going wheezing off and the other one was stopped, or vice versa. But Mayfly and Foresight were actually quite well matched. And I had a sail together with Ben for, well, at least a mile all the way across Portland Harbour, doing about 18, 20 knots. He was very slightly faster until he got a bit of ventilation down the foils and he would sink down and come back again. And over that mile or mile and a half, we were absolutely the same speed. He was convinced that my solution would work in the end. And I suppose Ben Ainsley's proved him right. Right, so despite the fact that it would all the time go around at 20 knots, there was some weird thing that happened on the measurement course where there would always be a hole in the middle. And so I couldn't get a speed greater than 17 knots, which was a bit of a disappointment. This was in 1978, which was a very quiet year. There was really very little wind. If you notice, the starboard float has got a grey nose, but I don't really want to tell you about that. You can see the two feelers out of the front running along the surface, keeping the whole thing stable. It's a fairly wet business. When the boat starts leaping up and down, that's because one of the foils is jammed, and I'm desperately trying to unjam it. Like that. Tacking was ever so easy, and on one luckily recorded occasion, the boat did tack completely on the foils. Now, whether this is the first time ever, I don't know, but it was recorded and it has been properly attested. So how you find out whether you're the first person ever to tack on the foils, I don't know. Unfortunately, trying to do it again broke the boat. One of the struts came out of the water and the other one bent. So the team banned any more attempts at that. So with this business about it wouldn't do more than 17 knots, that eventually it was agreed that the only way to do it was to go out in more wind. And this is the day which was blowing about 6, where we decided that was going to happen. Unfortunately, we'd left it too late making the decision and the tide was going out. So I set off, but I couldn't get up to speed without the foils touching the rocks. This was not good. And a great big gust came and I exited. Also, this here is the top of the mast coming off. So that was the end of Foresight, and it was, almost all of it was fine, but it became clear that there were so many fundamental things that had to be changed to make it work properly that she was retired. There was a little bit of work. Adrian Cudmore, I saw is here. He worked on trying to work out how we could have twin sails, which would allow a better way of supporting the sails. But in the end, it got sawn up and taken to the dump. And that was nearly the end, I suppose, except that Peter de Savary decided that he wanted to have a go at the America's Cup. And this was the America's Cup when the New Zealanders had a 90-foot monohull and had challenged. And the Americans decided that they would defend in a catamaran. And it was a complete walkover for the catamaran. But there was some doubt about whether it was legal for a catamaran to be the defender. And Peter de Savary ordered a boat which was a monohull. So there's no side hulls, it's not a multi-hull. It was a monohull which was supported by foils. And there was a guy in the middle with a pump, pumping the foils one way and the other to keep it upright. There was some correspondence about it, which I replied to, and I was invited to go down and have a sail. And it was very interesting. That's what these are temporary floats to keep it upright until you get it into the water properly. You can see the foils, very similar arrangement to mine, except they didn't have a tail foil. They didn't have a tail foil, which was to prove expensive. When you're a visitor on this boat, you're invited to sit right out on the very outboard end of the crossbeam. And when they tack, you have to nip across here, hurdle underneath the boom, nip over to the other side, lie on the end, and then they dip you in the water. So, right, any questions?
Doug, there's one in the message from Rod Little, who's asked, how was the angle of attack of the leech flap controlled or fixed?
Say that again?
How was the angle of attack of leech flap controlled or fixed?
Well, it was set at the maximum angle, which I thought before the flap would stall, because the basic idea was all I needed was more lift. So there was no element of control. It was just banged on one way or the other.
Yeah, sort of fixed trim tab, is it?
Yeah, it was just a trim tab. It seemed to have very little effect on the sail at all. So, I mean, it may have done a bit, but you couldn't tell.
Just one other quick one, looking at what's happened since.
Yeah.
What do you think would have been most beneficial to you to have had the advances that have been made in aerodynamics, hydrodynamics, or in material science and the extraordinarily light and strong materials we have now?
Yeah. Weirdly, these craft are not very weight sensitive. It didn't make much difference if the boat had been much lighter. So although, I mean, the place where materials would have helped would have been that maybe I could have had foils with a bigger span. They were fairly short. The mast might have been a bit lighter, but really that wouldn't have made much difference. No, I think the fundamental thing that would have made a difference was if somebody else had built it first, and I could have said, that's what you've done wrong, and then do something different. I never really came up with a follow-on design. There were boats which were built which clearly benefited from the sort of ideas that I had. And there was a boat called NF Squared, an American boat, Professor Bradfield, I think. And he'd been down to Portland and seen the boat. and they came up with a boat similar trimaran configuration, 3 foils, fully submerged foils, but more sensible sails. He had sails like 2 windsurfers, and that was a much more sensible thing. And it ended up with Hobie brought out a hydrofoil boat of their own, Hobie trifoil or something. I don't know if you can still buy one. The only problem I saw with it is that, oddly enough, it's a bit boring because it just goes.
Motorway sailing.
Yeah, it's very strange, really. I mean, I had the advantage that it didn't just work, and so I was constantly fighting the machine. But if it had all just been working, then you just drive along. And then I had I had no involvement with the sail whatsoever.
Thanks very much.
You're welcome.
Doug, I had a question on the sail plan that I think you
Yeah.
showed. There was something called a vortex generator.
Oh yeah, yeah.
What was that?
Well, shall I go back and share screen again?
Yeah.
How do I get out of that? Oh, I know. Oh yeah, yeah. Well, one of the problems with a sail of this shape, which is untwisted. I mean, we all have sails this shape. The jib on my 15 is even more extreme than this in many ways. But our sails are all twisted, twisted off at the top so that they will work properly. This one couldn't be twisted, and there was a problem with it, with the tip stalling out before the rest. And the idea of the vortex generators was that would prevent the stall at the tip of the sail. To find out if it worked, I put them on one side and not on the other. And I could tell no difference between the 2 sides.
So what were they? Were they a sort of, I don't know, a sort of embossed
little,
ridge or something?
little plastic triangles.
Oh, right.
Yeah.
Okay.
Highly untechnical, just little bits of Melinex folded and stuck on.
Amazing. Great, thank you.
You're welcome.
Are there more questions from anyone?
Oh, there's Adrian. He was trying to help me design a new sail.
I mentioned to you, Doug, some time ago when we talked about this, it's Rob here,
Yeah.
that my family doctor, when I was a youngster, was Dr. Gagono.
Oh, right.
And he and my father built Icarus, which was the tornado that was foiling in the early 70s.
Yeah.
And I just wondered if you ever came across them, because I think Dr. Gagono, from my recollection, went on to windsurfing after that. I mean, he was a bit of a lunatic, to be honest, and he built one of the first balsa wood windsurfers that was about a metre long. I mean, literally about a metre or a metre and a half long, and got some silly number out, like 30 knots out of it or something like that.
Yes, we did know them. They were sort of dread rivals. Yes, we knew what they were doing and they knew what we were doing.
So I ended up having a go at this because Doug was a professor at UCL at the time, university, and I was doing an MSc. And Doug said, "Oh, you could have a go at designing a new sail for me." Oh, okay, yeah, sounds fun. I'll have a go at that. So I did that as my project and designed a sail very similar to the one he had. And then there was an American boat, I think it was called Longshot, which the Hobie boat evolved from. And they had introduced the twin sail arrangement. So there was me thinking I was sort of two-thirds of the way through my MSc project and doing all right. And Doug says, "Have you looked at this?" And then start again. So 2 smaller sails, but it was quite interesting and a bit challenging.
Well, I did actually try to build a model, just a couple of metre long model of the rig. And I found that it was almost impossible, even at that scale, to get the sails up, because these were going to be rigid wings again. But you'd get one in position and the other one would fall down. You needed a lot more hands than I had. And I didn't honestly think it was practical. But it was, well, it was a fine project. It just failed.
Well, I mean, it was Gavin Rudgley and I. So Gavin was doing the structural design, and I think we actually came to the conclusion we needed a crane to erect it.
Yeah, absolutely. And of course, that's what the America's Cup boats have got.
Yeah.
Yeah.
It was good fun.
So when you were doing all this, Doug, could
Yeah.
you have imagined that 40 years later, there would be sort of 75-foot yachts foiling around at 50 knots?
Of
Because
course.
well, yeah, I mean, actually, 40 years feels like actually quite a long time
This
in
is
the
a long
context of change nowadays. I mean, where did you imagine it would go to when you were
Well,
doing this?
Well, Ben Wynne and I got together to write a paper for the Hydrofoil Society or something about the future of this. And we produced a paper which said that we would have hydrofoil yachts and cruise liners and all the rest of it whizzing about the place. Whether we believed a word of it was another matter, but we did get a prize for the paper. So yes, we could see that it had a way to go. But, you know, Ben's boat is 3 times the size, got the most wonderful rig. I mean, that rig is fantastic. Such a pity that they can't have stabilization built into the foils, which would be ever so easy, like a moth, basically. But no, it's fantastic. It's fantastic. I mean, I'm sure you know the sort of boats that have been doing really high speeds. I produced a slide for that. There we go. There's a way of getting this to go more quickly, but I don't know where it is. Oh yeah, these are some of the speeds that are measured. So the Vestas sail rocket 2 is up at 65 knots. And if you haven't watched the video of that, you really should. It is absolutely astonishing. It only has 2 points touching the water, and it is an amazingly efficient design. Next behind him are the kite surfers, and they, as far as I can see, are completely mad because they're standing on a little board. The kite is attached to their tummy button, and if they come off, the chances of them being able to disengage the kite seem slight. So they just carry on up the track at 50 or 60 knots attached to this crazy kite. There was a kite boat at Portland when we were there. It was a Tornado catamaran hull with a C-class C-class kite to power it. And we were wandering past one day and they had the kite up, and in order to launch the kite, they had a screw driven into the beach. So they had the kite attached to the beach, and they got the kite up and going. And then they had to transfer the kite from the screw to the catamaran, and something went wrong. And at that point, they got it attached to the catamaran, and the catamaran went straight up in the air about 20 feet, and all the people fell off. Kites are frightening things. There's a thing called l'Hydroptère, a French boat, which is an ocean-going trimaran, surface-piercing foils. I don't know how big she is, about 50 foot, I suppose, 40 or 50 feet. But she can go out in high winds. And so she was doing 50 knots in sort of 40 knot winds. windsurfers are nearly up to 50 knots. And the trifoiler, which is very vaguely my sort of configuration, they got her up to just over 40 knots. So if I'd worked a bit harder, I could undoubtedly have got there.
Thank you.
The Hydropter thing, that was an offshore yacht, wasn't it? Because
Yeah.
I remember it actually sailed from America to Hawaii.
Yeah, that's right. Yeah.
I'm not sure they can stop. That was the problem.
Are there any other questions out there? I can't see everyone, but unmute yourself.
It sounds like you didn't win the £2,000, but did you ever get your stag?
No, no. But my little GT6 was a delight.
Yes, that looks nice. I like that.
No, we never got any prize money. We got a prize for best attempt or something. most likely to improve, something silly like that. But no, we never got anything really good for the work. But let's face it, it cost very little. As I say, almost all of it was made in the garage. For some reason, the glass manufacturers decided that they would give us the glass cloth for nothing. So that was a help. But,
Do you ever regret chopping it up?
often.
Oh well.
Gail doesn't.
No,
You have to build another one.
no.
No, I don't think we'll build another one. No. But on the other hand, I'm a member of the Royal Naval Sailing Association, and I noticed that they've now got some foil boats, a foiling laser or a foiling aero or something. And I must admit, I'm very tempted to get in touch and see if I can have a very, very brief go. I think the moths.
You'll be foiling your 15 before we know it, Doug.
I think not. I think not.
That will be a sight to behold.
Yeah, we could put foils on the westerly. Yeah.
Okay, are there any more questions? Doesn't sound like it. Well, Doug, I mean, I've been really looking forward to this, and it's not disappointed at all. It's been fabulous.
No, it's
really,
brilliant.
really great. So thank you very, very much. I'm sure everyone's enjoyed it. So round of applause, I think, for unmute yourselves and round of applause. Thank
you very much.
You're welcome. You're welcome.
Many thanks, Doug.
It's just a pity I never brought the boat down to Chew.
Yeah.
I don't think I would have been allowed because I might
wouldn't
have
have been allowed.
avoided the trout.
I'm sure we could have. I'm sure we could sort out an exemption if you wanted to. If you wanted to give it a go.
Okay. Yes,
Thank you very much. I think
happy
it's great.
sailing.
Yeah. Hopefully we can all get back on the water soon. If not, but
Yeah.
in the meantime, take care. Craig, are you going to leave the Zoom open for a while if people do want to linger and chat? I can't see him, but I'll assume he's nodding. But yeah. Otherwise,
Okay.
bye all. Take care.
Yes. Ah, can I leave? Yes, we can leave.
Dennis, my dog.
Thanks, Andy. Well done, Andy and Craig. Brilliant, and Doug.
Thanks, John. Yes, well done, Doug. Thank you very much. Fantastic. And thanks, Craig, for setting that up.